Hi, good morning, dear students. Hope all of you are good. You use these holidays effectively. Okay? Last class we studied what are acids and alkalis. Today we are discussing about how can we detect alkalis and acids. Robert Boyle, an Irish scientist, studied acid and alkalis and decided to try and find an easy way to identify them. When Boyle tested acids and alkali with the juice from purple cabbage, he found a way to identify them easily. When acid is added to purple cabbage juice, it turns from purple to red. When alkali is added, the juice turns from purple to green. He also found that juices from violet turned purple with acid and greenish yellow with an alkali. But his discovery about the color changes in litmus, a juice from lichen, went on to be used in chemistry laboratories around the world. Nowadays, the indicator we are using to detect acid and alkali is litmus paper. If you put a drop of acid on litmus paper, blue color litmus paper, it turns to red. Same like that, an alkaline turns red litmus paper into blue color. There are over 20 indicators that scientists use. Here are two examples. Methyl orange is pink in acid solution and yellow in alkaline solution. Phenolphthalein is colorless in acid solution and pink in alkaline solution. So scientists are used to litmus paper or other indicator to detect whether the given substance is acid or alkali. After indicator had been found to identify acid and alkali, scientists wanted to know how to compare strength of acid and alkali. So they invented pH scale. pH scale is an electrical instrument is used to measure the pH of an acid or alkali accurately. The letters P and H stands for the power of hydrogen because this is an element that is found in acids which takes an active part in their chemical reactions. Now we have to check how can we detect strength of acid and alkali using pH scale. I gave one pH scale here. You can see here 1 to 14. Most of the pH scale there are 0 to 14 and it runs means pH scale runs from 0 to 40. Okay. It goes left means what? The substance contain more acid. It moves right side means it contains more alkali. Then how we can identify the strength of acid or alkali? If the pH scale shows 0 means the substance contains the strongest acid. If it shows 14, it contains strongest alkali. Sometimes it moves 0 to 2. Okay, the pH scale moves from 0 to 2 means the substance contains a strong acid. If it moves from 12 to 14 means 12 to 12 or 13, the substance contains strong alkali. Weak acid has a pH of 3 to 6 and a weak alkali has a pH of 8 to 11 means if 9 is if it shows 9 means what? It contains the substance contains weak alkali. If it shows 1 means what? It contains strong acid. Like that. Understand? Okay. Then a solution with a pH of 7 is neutral. It is neither an acid or an alkali. Example, water. pH of water normally shows 7 because it has no it does not contain acid or alkali. Okay. Now we have to look what are the main difference between alkali and acid. The table on the slide shows the main differences. The taste of acid is sour, the taste of alkali is bitter. In the case of acid, blue litmus turns to red, but in the case of alkali, red litmus turns to blue. Acid contain H plus, alkali contain OH minus. This last point you will study in higher classes. Okay. Next one is a new term, that is neutralization. Do you ever heard about neutralization? I think no. What is meant by neutralization? When an acid reacts with an alkali, it forms salt and water. This process is called neutralization. This reaction can be written as general word equation. Acid plus alkali means acid react with alkali. It changes to what? Salt plus water. Salt and water. One example is given here. Hydrochloric acid react with the sodium hydroxide. It forms sodium chloride and water. Sodium chloride is salt. Okay.